Good morning. So today we will see the demonstration of the testing of air circuit breaker. So already we have discussed in the practical session last time that brief construction of the air circuit breaker and the 4 different tests which are performed on the air circuit breaker, that already I have explained during the discussion. So today we have the demonstration of that air circuit breaker. So let us see the air circuit breaker in our SGP laboratory. So here this is our air circuit breaker. You can see various parts of the air circuit breaker here. So I will just demonstrate you. So here you can see these are the, at present you can see these are the contacts of the circuit breaker, and you can see the contacts are in open position. So this air circuit breaker is presently open. Okay. So as we have seen in the construction, air circuit breaker consists of two set of contacts. One is the arcing contact and second is the main contact. So here you can see these are the arcing contacts I am showing over here. So these are the arcing contacts, and above arcing contacts these are the main contacts, and just attached to this main contacts, so these are the what we can say, these are the arcing contacts, and these inside one are the main contacts. Okay, so the main contacts are going to open first, and thereafter the arcing contact going to open. And with this arcing contact you can see here this V-shaped arc runners are there. So with this arc runner we can have this high resistance interruption principle is utilized here. Now besides this main contact and arcing contact, we have here this operating mechanism is the spring. So here you can see the spring operated mechanism, and then various mechanical linkages are there. Through these mechanical linkages the signal is given to these contacts so as to activate the contact from open position to the closed position. Now here on this side you can see these incoming and outgoing terminals. So this is incoming and outgoing terminal for R pole. Similarly this is for Y pole and this is for V pole. So incoming and outgoing terminals. Then on this side you can see here the different releases. So I have talked about these are the mechanical linkages through which the signal is passed in order to activate the contacts. So later on we will see how this air circuit breaker can be operated. So here you can see now this air circuit breaker, which is LNT-MEC CNCS 630, it contains or it consists of 3 releases. So this one is first one, this is called under voltage release. The lower one is shunt release. So the purpose of upper one under voltage release is to provide the under voltage protection. The purpose of this lower one shunt release is to provide the remote tripping. So for remote tripping purpose this is used. Then on this side you can see on this side third release is there. So this one is our DN1 release. So this DN1 release is basically provide us overload protection as well as short circuit protection. So here you can see there are total 13 terminals. As I have told, the first one is S terminal, and then after that you have we have M2, M1, S1, S2. So these 4 terminals plus another 4 terminals for second pole and one more 4 terminals for third pole. So this means 12 plus this one is S. So in all total 13 terminals, right? Then between S1 and S2, between M1 and T1, T2, between T1 and T2 we have M1, M2 and T1, T2. Okay, so between T1 and T2 the thermal bimetal is provided. So during the overload test we will connect these 2 wires between T1 and T2, whereas during short circuit test we will connect these 2 wires between S and M1 or S and M2, because between S to M1 or S to M2 our magnetic pickup coil or solenoid coil is there, right? So that is really for the short circuit protection. Then here you can see the current setting arrangement. So this will provide the current setting. Now what kind of current setting provided, that before that we will see here this ACB contains CTs. So here you can see 3 CTs. On this side, I will show you. There are 3 CTs. There are 3 CTs. Yes, see here. This is first CT, this is second CT, and this is third CT. Okay. So you can see that these 3 CTs, one for each pole. So this air circuit breaker contains CTs. So see, the CT primary is provided with tapping. So this is common, and thereafter this one is 400 ampere, then this one is 500 ampere, and this one is 630 ampere. So all these are marked here on this CT. If you closely see, you will see that this first one is 400, then this one is, second one is 500, which is written on this side 500, and this one is 630 ampere. So presently it is connected between common and 630 ampere. So the primary CT current is 630 ampere in right now. So we can change this to any of the tap, like 400 ampere or 500 ampere, depending on the load condition. Okay, depending on our load requirement, we can change this or set this particular tap. Right now, all these L&T make ACBs which contain CTs, its CT secondary current is 8.75 ampere. So the CT secondary current of all these 3 CTs is 8.75 ampere, and through this we will perform this overload test as well as short circuit test, because while performing the overload test, either we have to pass or either we have to overload from primary side or we have to overload it from the secondary side. So if you have to perform it from primary side, so primary current is 630 ampere. So to pass or to perform the overload test, we have to pass 1.5 times, 2 times and 3 times of 630. That means approximately we require a 2 kiloampere current source, which is quite huge. So that is very difficult to have such a large capacity current source. Therefore, what we will do in the overload test, we will inject current through CT secondary. Okay, and CT secondary is at lower magnitude, 8.75. So by passing the current with a base of 8.75 in the multiples of that, that is 1.5 times, 2 times, 3 times, and keeping the primary of course open, we can very well perform the overload test. Same thing we will pass during the short circuit test also. We will inject the current through CT secondary, that is with 8.75 as the base. We will pass 5 times of that. Okay, 5 times of that or 7 times of that. If you have to use terminals S and M1, we have to pass 5 times of the 8.75 ampere current, and if you have to use S and M2 terminals, then we have to pass 7 times of the 8.75 ampere current as per the instruction given by L&T. Right, then now let us see the operation of this air circuit breaker. Now you can see here one handle is provided. So this is the manually operated air circuit breaker, and on this handle here you can see it is written off. Here it is written off. That means at present the circuit breaker is in a off condition, right? So circuit breaker is in a off condition, and here one push button is also there. This is there in order to trip the air circuit breaker manually. Okay, now see, first in order to close the circuit breaker, we have to first get the spring charged. So I will first get the spring charged. You can see here the spring, with this action the spring getting charged, isn't it? So you can see the spring get charged, right? Now only the spring get charged, right? Now in order to close the contacts, you can see here only spring get charged right now, and the contacts are still in the open condition. Now in order to close the contacts, I will push this handle with one more action, so that whatever energy stored in the charged spring, that is utilized to latch the contacts of the air circuit breaker, and breaker get closed. Let us see. Now see, here the contacts are in a closed position. The contacts are totally closed, right? So in this way we have closed the circuit breaker, and here on this side you will get the indication that the circuit breaker is on. Here right now you can see ON on. So the breaker is in a on condition. The breaker is closed right now. Now in order to open the breaker, I have to press this trip push button. So once I press this trip push button, then you can see that this contacts will get open. So I am pressing this push button, you can see now the contacts will get open. See here. So in this way the contacts are open now. The ACB is in an open condition. Okay, and here we will get the indication OFF off. So in this way we can operate the air circuit breaker, right?